Hello everyone, today I'm going to show you how to train Inception V3 deep learning model on a multi-class dataset. Our dataset is a flower dataset and it has 5 classes: daisy, dandelion, roses, sunflower and tulips. Inception V3 is a deep convolution neural network designed by Google research team. It uses Bayes normalization activation function to speed up training and improve generalization. This network uses convolution layer instead of pooling layers. In this tutorial, we are going to cover the following steps: installing and importing necessary packages, dataset loading, data augmentation techniques, early stopping. So early stopping is a regularization techniques that used to prevent the overfitting. So I'm going to discuss it later. Performance evaluation on some sample test data, visualizing the accuracy and loss graph, testing our model on some sample test data, saving and loading our model, confusion matrix. A confusion matrix is a table that will compare our actual prediction with actual label with predicted labels. Finally, we will evaluate the accuracy, precision and recall. So this is a complete tutorial. So everything's we are going to see here, like it is a complete. We're going to do all of these things for a deep learning model. So about me, I'm Dr. Norman, PhD from Edith University, Australia. Before beginning, if you are not familiar with what software do you need, how you can create a Python environment, I can recommend you to watch my first video. I am giving the link of this first video in this video tutorial section. Now let's get started. So this is the dataset: test, training and validation. So training has 5 classes, test 5 and validation. So we're going to train our model on the training dataset, validate our model on the validation dataset, and finally we'll evaluate our model performance on test dataset. And we will see our model prediction on some sample test data. We will also see some confidence score as well. So this is whole dataset. I am going to share this dataset, my code and my link of my playlist, everything in the video description section. Now let's get started the coding. So these are the packages we need to install for this deep learning model. So we need TensorFlow, matplotlib, scipy, plotly, scikit-learn, keras, numpy. You can write down that pip install the package name, then it will install all of your packages. So now this, after installing, so we need to import all the packages because we are going to use all of these packages here. So we are importing all the packages. So these are the image sizes, 299 by 299. We are going to resize all of our training, test and validation images 299 by 299 because this is standard image size for the Inception V3 model. And these are the image paths, so training paths, validation path and test path. So now we are loading our Inception V3 model with ImageNet weight, and we are going to include top equal to false because we are adding some extra layer in this base model. So this is our base model with ImageNet weights, and we will add some extra layer here. So we are going to freeze the base layer because we don't want to lose our existing weight during the initial training. So that's why we are going to freeze the base layer. So this is the folder structure. So it will automatically take the final output for your model. So if your dataset has like a 10, 100, whatever the classes, it will take the model automatically in the model output. So we are going to, so our dataset has 5 classes. So if your image dataset has like a 10 or 20, it will, don't worry about this one. You can train the model on any dataset. You can train this model on any classes dataset. So these are the extra layer we are adding because we are going to add the final 5 output layer, and we're going to activation function is softmax or multiclass. Normally we use the softmax activation function. So After adding some extra layer, now we need to combine our base layer with added layer. So we need to add these two together and creating the object model. So now we can see the model summary here. So we can see the model summary. This is the whole model summary. You can see the everything's here, the convolution layer, activation layer, everything. So you can get an idea from here. This is, and final output, you can also see the final output layer is 5. So final output will be the 5 classes. It will predict the final 5 classes output. So now we are going to compile our model. Before training, we need to compile every deep learning model, and we are going to use the categorical loss function because our dataset is categorical, 5 classes, and we are going to use the Adam optimizer, and accuracy and matrix is accuracy. Now we are doing some data augmentation here. So we are rescaling, sharing the images, zooming the image, horizontal flipping. So this data augmentation technique may give you more training sample in your training data. It is good for making more generalized model. So if you add more like vertical flip, more data augmentation technique, it will give you more good model. So after data augmentation, we are going to load our data set. So training, so we have 1760 training images into 5 classes. Validation, 438 images, 5 classes. Now we are going to use our early stopping. So early stopping is like our regularization technique. So we can monitor our validation accuracy, validation loss, or training accuracy or training loss, and we can stop our model anytime. So if you put epochs 2000 and you use the patience 20 and you are monitoring the validation accuracy, means that if there are in consecutive 10 epochs there are no validation accuracy improvement, then your model will automatically stop and you will get the best saved model. So if the trend, we can put patience 10, 20 or 50. If there is 50, if you put 50 here, then if there are no consecutive 50 epochs, there are no validation accuracy improvement, then it will stop the model training. So you can put any 10,000 epochs or 20,000 epochs. If you put the condition here, it will automatically stop. So it will help you to prevent your model from overfitting. So now we can validation accuracy or loss, monitor the loss. So early stopping is very good for your model training, and we are calling this early stopping here, callbacks equal to early stopper and checkpoint. So we are calling the early stopping and we are saving the checkpoints, and we are putting here any number epochs you can put. So you can put like a 10,000 or 1500, whatever you need, like, but I'm going to show you. So just like I'm putting very small number of epochs, like a 30 epochs. So now training started. So now we can see this is the training accuracy. So if the model, during the model training, you can see the training accuracy and validation loss. So validation, if the training accuracy is improving and loss is decreasing, that is good. Like you can see the training accuracy is improving and loss is decreasing. This is training. After the one epoch, we can see also the validation accuracy and validation loss as well. So I am going to wait until one epoch finish. So after one epoch, we can see the validation loss improve to 3.78 and saving the best model. So this is a good way we can prevent our model from overfitting. So now I'm going to pause our the training until it finishes the 30 epochs. It will take time, so I'm going to pause. We can see the model has completed 30 epochs, so now it's good. Like we can see the performance of early stopping. So in the 20 epochs, so early stopping worked. So in the last, after 10 epochs, there is no validation loss improvement, so that's why it stopped the training. So you can see there are only 20 epochs training. So after 20 epochs, we can see, so we put 30 epochs, but it early stopping stop our training on 20 epochs. So after 20 epochs, we can see training accuracy is 95% and loss is 0.66. validation accuracy is 88% and loss is 3.13. so on actual training you need like a 2000 or 3000 epochs with patients with 30 or 40, so it will be good to get a good model. So now we are going to see our training and loss graphs. So this is the comparison between training accuracy and validation accuracy. So you can see it is improving. So it is almost, training is 95 and validation is more than 85. Yeah, and so loss is decreasing. So the training loss and validation loss both are decreasing. That is good. So now we can save our, so we already save our best model from here. We don't need to save that, but you can also save the best model here. And now we are going to predict some sample. So we are going to see the confusion matrix. So confusion matrix is a table that will give you the comparison between the actual label with predicted label. So it is taking all the test images. So this is the test images. It is taking as input and it will give you the confusion matrix. So after taking all the images, training images, we can see this is the confusion matrix. So there are 5 classes: daisy, dandelion, roses, sunflower and tulips. So we can see this is diagonal. It will give you the correctly prediction. So daisy, there are 87 images, they correctly predicted as a daisy. 7 images it corrected as a dandelion, that are incorrect. 1 images, so 7 daisy images that incorrectly predicted as dandelion. 1 daisy images incorrectly predicted as roses. 3 daisy images incorrectly predicted sunflower, like this way. Now dandelion, so 0 dandelion images predicted as daily. So daisy, 125 dandelion images are predicted correctly, and 0 is predicted dandelion images predicted as roses. So this is the confusion matrix. You can see the confusion matrix. So now we are going to see the precision recall, F1 score and accuracy as well. So this is test accuracy 87%, precision is 88.88, recall is 87%, F1 score is 87. So now we can see everything. So now we are going to test some sample test images. So this is our testing images. We can predict any images, like a 25, 6. We can see the 6 as well. Even a 6. So it is correctly predicted roses. We can see any images. We can predict. We can see 38 is. We can see 38. Any number we can 38. That is dandelion, and it is 88% confidence that is dandelion. So now, thank you for watching this video. Please like, share and subscribe, and if you put any comments on any error, just put on the comment box on the video, then I will reply you soon. Thank you everyone again. Thank you.